Hello everyone, my name is Miskana Astulu, and in this brief overview, I'll walk you through the fascinating story of calculus and its expansion in the 18th century. We will look at key mathematicians, groundbreaking developments, and how these ideas shaped the world during the Enlightenment era. Let's dive in. Although calculus officially took off in the 18th century, its roots lie in the late 1600s. Two giants, Isaac Newton and Gottfried Leibniz, developed the car concept independently. Newton focused on motion and fluxions, while Leibniz introduced the notation we use today, like the integral sign and d for differentials. Their priority dispute caused tension, especially between English and continental mathematicians, but both made monumental contributions that became the foundation of modern calculus. In the 18th century, calculus flourished across Europe. Leonhard Euler, arguably the most prolific mathematician in history, applied calculus to mechanics, astronomy, and fluid dynamics. He introduced modern function notation and helped unify mathematics. Lagrange took a more formal approach, trying to build calculus entirely on algebra and limits. These thinkers helped make calculus a central tool in science and engineering, with their ideas spreading from Switzerland to France, Russia, and beyond. One of Euler's lasting impacts was his clean, elegant notation. He introduced the notation f of x and used e for the natural base. He also explored infinite series and convergence, key ideas in analysis. Meanwhile, Lagrange developed a new way of understanding mechanics using derivatives known today as Lagrangian mechanics. These developments paved the way for the more rigorous definitions of calculus that would come in the 19th century. The 18th century was a time of intellectual awakening. The Enlightenment promoted reason, science, and progress. Scientific academies in France, Germany, and Russia provided funding and community for mathematicians. Early industrial and engineering problems were also drove the demand for better mathematics. Calculus wasn't just a theoretical tool, it was increasingly applied to physics, navigation, economics, and even architecture. The impact of 18th century calculus is still felt today. It laid the groundwork for modern analysis, which in return supports much of science and technology. Later, mathematicians like Cauchy and Weierstrass would define calculus into a rigorous discipline, but it was Euler and Lagrange who made it usable, teachable, and powerful. Their ideas echo in every physics textbook, economics graphs, and engineering simulation today. This is really, really amazing. The foundation of modern analysis influenced physics, economics, and beyond, inspired 19th century rigor, timeless relevance. Calculus isn't just a set of rules, it's a story of human curiosity and problem solving. From Newton's falling apple to Euler's elegant equations, we see how deeply math connects with the world around us. Understanding its history helps us appreciate its beauty, power, and purpose. Thank you for Joining me in exploring this remarkable chapter is the story of mathematics.